Well, good morning, class. Getting set up here. Okay, I'm in Alaska. I'll see you on Friday at our Zoom meeting, and then in person next week when we do Module 2. But I've got a video here for you for Module 1. Real simple module. Probably don't even need me except for one topic that's new. The rest of it's all review, mathematical principles. So we'll go over it, and then because it is going to be quiz, we will get a quiz on it. So let's go over it. Module 1. Okay. And for some of you that are new, there's a couple of you that are new students. My name is Mr. Mann, Marty Mann, and I'm your chemistry teacher. And we're going to have a lot of fun. If you work hard, chemistry is not easy, but it's not hard if you work at it. If you work at it, it actually clicks, and then it becomes real rewarding. Because not everybody gets it because they don't work hard enough at it. But if you work hard enough and you listen to me, you will be successful and you will actually enjoy yourself. I promise you, you will. And I understand it, so I can teach it, and I'm looking forward to you guys learning more than what most high school chemistry students will learn. Anyhow, let's get back to it. Module 1, measurements and units. Okay, chemistry is the study of matter. Matter is anything that has mass and takes up space. Okay, so this has matter. Okay, it is matter. It takes up space and it has weight. Chemistry is the study of matter. Almost everything is made up of matter. Mass is similar to weight, although different, because weight is dependent on the influence of gravity. Now, remember this, because I'm going to ask you about this, okay? Mass is similar to weight, and a lot of times students like to interchange the words mass and weight as being the same thing, and it's not. Mass is not dependent on where you are measuring it. You could be on the moon and measure the mass of this pen, and you can be on Earth and measure the mass of this pen. It will be the same. However, if you measure the weight of this pen on the moon, it will weigh differently than what it will weigh on the Earth. So weight is dependent on where you're making the measurement because it has an influence of gravity. Mass is not influenced by gravity, therefore the measurement remains constant no matter where you're at. So you could be on Mars and the mass of this pen will be the same as it is on Saturn, as Venus, as on Earth, but the weight will differ. Okay, so that's the difference between mass and weight. Okay, mass is constant where weight can fluctuate depending on where you're taking the measurement. Now mass is measured by a unit known as the gram. Of course, we can use gram to make measurement of weight. Okay, if we're measuring mass and weight on Earth, they'll be the same. If we're measuring mass and weight, one on the moon and one on Earth, they won't be the same. But the unit will be grams. Okay. Now grams, of course, you have lots of different, you can add prefixes to it, kilo, mega, micro, milli, all these different prefixes to change gram into another, to change the decimal place of where it is. So milli means 1,000, so a milligram is 1,000, 1,000 milligrams is 1 gram. That's the beauty of the metric system, is that it uses these prefixes and they're consistent, where the unit English unit system is not consistent, and we're going to learn that in a second. But anyhow, gram is the basic unit that is used to measure mass. Now, just mentioned it, metric system versus the English unit system. The English unit system is what we are most aware of because we live in the U.S., but the world mostly uses the metric system. The English system is used in the United States. It may be used elsewhere, but I'm not familiar. And unfortunately, in the United States, we use both the English and the metric. English, if you are not a science major, you're just, let's say you're going grocery shopping and you want to go buy a gallon of milk. Gallon, that's an English unit. If you were buy that milk in Germany, it wouldn't be a gallon. It would be measured in liters because they use the metric system. However, in America, United States, we use the English system and the metric system. If you're a science major, you use both. And that can get a little confusing, and it just creates a little extra work for us, but it is what it is. So the English unit system is what we're most aware of because of our daily living, going to the grocery store, buying milk, things like that. The U.S. system uses the system along with the metric system, like I mentioned. Examples of the English system would be inches, feet, mile. If we're measuring length, that would be miles per hour. That's an English unit. In liquid, if we're measuring volume, it would be quarts or gallons. Cups. If we're using time, it would be seconds. Seconds is the unit of measurement for time. And oddly enough, in the metric system, seconds is also the unit used for the measurement of time. However, for volume and length, totally different system. Okay, the problem with the English unit system is there's no consistency. So you have to memorize a bunch of stuff because it's not consistent across the board, where the metric unit system is. So let's look at the metric unit system. It's standardized, universal system used throughout the world. Examples are gram for mass, meter for length, and liter for volume. And again, second is a unit for measuring time. All you need to remember are the prefixes that mean something that you can add to these basic units like gram. You could add milli or kilo, and it means something. It's consistent, and it's a different unit of measure, but it's built off the foundation of the constant unit of gram or for weight or mass. See, I just use weight and mass interchangeably. Volume would be liter, and length would be meter, millimeter, kilometer. Okay, depending on what you're measuring, you use prefixes to the appropriate prefix to use it. But it's universal. It's consistent. It makes logical sense. Okay, we will use the metric system almost exclusively, not entirely, but almost exclusively in chemistry. Okay, and in physics if you take physics. So the prefixes in the metric system are micro, which is if you look in the notes, you'll see this funny little. Let me get my board. You'll see this funny little sign. Micro is abbreviated by mu. It's called mu, if you see that. Mu. That means micro. And that's for measuring very, very small things. If I was measuring in a lab something that was very, very tiny, micrograms, and since we were measuring mass, micrograms, very, very small. It's numerical values 0.000001, so to the -6. So you move the decimal places 6 spaces to the left, to the -6. That's a micro, so very, very small. Milli, of course, abbreviated by M. This is to the thousandth, so it's 3 decimal places to the left, or 0.001. Okay, if we're using 1 as our foundation, our base. Centi means 100, abbreviated by C. Movement decimal places 2 places to the left, to the -2. That's 0.01. Of course, deci, then we're on the other side now. We're going up instead of down. Deci is, I'm sorry, we hitting right there yet. Deci is to the 10th, so 0.1. Move decimal places to the -1 to the left. Then you have deca, which is capital D, hecta, capital H, or kilo, little k. So hecta would be 100, kilo is 1,000, meaning you would move the decimal place. For hecta, it would be 3 places to the right, or 100. For kilo, 4 places to the right, or 1,000. Mega is capital M, and that is the prefix that means to the millionth place. So it's 6 places to the right, the opposite of the mu, micro. So, for instance, if I had 1 kilogram and I wanted to know how many milligrams were in that, I would move my decimal place 6 places to the left. Why? Because kilo is 1,000, 3 places from 1 gram, and milli is 3 places to the left of 1 gram, to the 1,000th of a gram. So it would be a total of 6 places. So one kilogram would be, I got it screwed up. You move it, 1 kilogram would be 1 million milligrams, or 1,000 grams if I wanted to use grams. This should be all review. I'm not going to beat myself up trying to teach this to you, because this is something you guys have learned in the past, and you just need to review it and be ready to go with it. It's something that's already in your head. I don't need to teach it to you again, but we're going over it real quick. Converting between units. So what if I wanted to convert between units? Let me get the book. Okay, I'm back. Got my book. We're going to go to example 1.1 of module 1. Okay. Let's see here. 1.1. Okay. A student measures the mass of a rock to be 14,351 grams. What is the rock's mass in kilograms? So it wants to convert from grams into kilograms. Remember, grams, there's 1,000 grams for every kilogram. Okay? Or there's 0.001 kilograms for every gram. If I have 14,351 grams, how is that? How many is that in grams? Well, let's see here. You could probably do this in your head, but we'll do it up here. It's 14,351, I think was the number. I could just move my decimal place, because here's going to be where my decimal point is. I could move it 3 places. It would be, what's the question? It says if I have 14,000 grams, okay, I want to know how many kilograms that is. I can move the decimal place 3 places, from 1, 2, 3. So the answer is going to be 14.351 kilograms. Okay, just by moving by decimal point, because I know what the prefixes mean. However, you don't have to have, you could do it this way too, 14,351 grams, and you could set up an equation, okay, an equation that will allow you to cancel out grams. How many grams are there in a kilogram? For every 1 kilogram, there's 1,000 grams. Why did I put 1,000 grams in the denominator? Because I want to cancel the grams out. This allows me, this equation, this relationship here, if I put it correctly, the denominator, the grams, and the numerator, the kilograms, I'm able to cancel out my grams. And what do I end up with? Kilograms. So 14,351 times 1 over 1,000, or you could say 14,351 divided by 1,000. That should equal, you put that in your calculator, it will be 14.351. And what's the unit? Kilograms, because the grams canceled. You end up with kilograms. Either way, you can move your decimal because you know in your head what the prefix means and you know which way to move your decimal, or you can set up an equation where you can set it up so this relationship that you have memorized, there's 1,000 grams for every kilogram, you set it up so that the kilograms in the numerator, grams in the denominator. Why? So you can cancel out your grams, end up with kilograms, because that's what the problem is asking you. It's asking you to convert grams into kilograms. This allows me to do that. I get the same number, because this equation is basically what I'm doing in my head when I do move my decimal. Okay? So that's one way to solve, there's 2 ways to solve that problem. Okay, again, you should probably already know how to do this, because this is stuff that's taught in grade school. Okay? But we're reviewing it. What about converting? And look at the notes. It says converting between unit systems. In other words, moving from English to metric or metric to English. How do we do that? Well, we have to do some memorization, unfortunately. You have to memorize these things. I want you to know, commit these to memory. I want you to memorize that 1 inch equals 2.54 centimeters. 1 inch equals 2.54 centimeters. I actually use that all the time, even in my daily life. I do. I use it all the time. 1 gallon is 3.78 liters. I don't use that very often, but I want you to memorize it for this class. 1 gallon equals 3.78 liters. And then there's going to be another thing I'm going to have you memorize in a little bit, but those are the 2 I want you to memorize first. Now, let's look at example 1.2 in your book. 1.2, it says, the length of a tabletop is measured to be 37.8 inches. How many centimeters is that? Well, if you didn't memorize that for every 1 inch, it's 2.54 centimeters, you couldn't figure out this problem. Okay, because you have to have that in your head to be able to make the conversion from inches into centimeters. You have to know what the relationship between inches and centimeters are. So let's set up an equation that solves that problem. Okay? It's 37.8 inches. 37.8 inches, and it wants to know how many centimeters that is. What's the relationship? 2.54 centimeters, I memorized that, is equal to 1 inch. That's the relationship I had to memorize. See, using the metric system, you just have to memorize prefixes. Here, I have to know this relationship by memorizing how many centimeters are an inch. Now, I set up this equation so that the inches are in the denominator, so that my inches will cancel, and I'll end up with my unit being centimeters, because that's what the problem is asking me to do. 37.8 inches times this relationship set up correctly with 2.54 centimeters in the numerator and 1 inch in the denominator will allow me to cancel out the inches, and I end up with centimeters. What's 37.8 times 2.54? The book says it is 96.012 centimeters. So we'll just round it to 96 centimeters. That's the answer. How did I do it again? I knew the relationship between centimeters and inch. I set up an equation where this relationship was put where for every 1 inch there's 2.54 centimeters. I put this in the numerator instead of the denominator. That way I could cancel out my inches and end up centimeters. If I flip this, the relationship's still the same, but it doesn't allow me to cancel it. So I got to make sure I put it I orient it correctly in the equation to be able to cancel what I want to cancel and get what unit I want. Okay? Again, only way to know how to do that is you have to know this relationship by memorization. Then set up the equation correctly. That's how it's done. Okay? All right. Moving on. Converting between units. Example 1.3. All right. The length of a... I'm sorry, it was 1.2. Let's go to 1.3. Okay, the mass of an object is measured to be 0.030 kilograms. What is the object mass in milligrams? Okay, so we're within the metric system. All I have to know is that I'm going from kilograms to milligrams. Okay, that means I got to set up an equation. I can move the decimal 6 spaces. How do I know 6? Because kilo is 1,000th of a gram. Kilogram is 1,000 grams. Milligram is 1/1000th of a gram. So that's a total span of 6 decimal places. I could move it. The answer is going to be 30,000 milligrams. For 0.030 kilograms, I move it a total of 6 spaces, and I'll end up with 30,000 milligrams. But I could set up an equation to do the same thing. How do I do that? If you don't want to move the decimal, because that doesn't make sense to you, or you're scared of making a mistake moving it so many places, you can set up the problem like this. 0.030 kilograms. And I want to get to milligrams. How do I do that? First thing I got to do is set up a relationship, an equation with the relationship. How many for every 1 kilogram, there's 1,000 grams. Okay? Now that gets me to grams, but it doesn't get me to milligrams. Fine. I can then add another part to the equation. I can go from grams now. There's 1,000 milligram. I'm sorry. Put it in the wrong spot. 1 gram is 1,000 milligrams. Do you see what I've done here? The first step number 1, I was converting kilograms into grams. How do I do that? I set up the relationship. There's 1,000 grams for every 1 gram for every 1 kilogram. Kilograms get to cancel. What's 0.030 times 1,000? That's going to be 30. Then I take the next step, step number 2, and I convert 30 grams into milligrams. Okay? I probably should have broken this down for you. So let's just back up, make this simple for you. What's this? Step 1, converting kilograms into grams. There's 1,000 grams into a kilograms. What's this? This is going to be 30 grams. Why? Because the kilograms cancel. I end up with grams. I end up with 30. I've moved the decimal point 3 spaces, which makes sense because it's 1,000. Step number 2, I'm going to take 30 grams and I want to convert that into milligrams because ultimately that's what the problem is asking me to do. So how many milligrams are there in a gram? There's 1,000 milligrams. I put that in the numerator and I put grams in the denominator. Why? Because I want to cancel out the grams and end up with milligrams. What's 30 times 1,000? 30,000. And the units is milligram. That's one way to do it. Setting up equations. You set up equations based on relationships, the prefix relationships. Or you can, in your head, move the decimal point because you know, in your head, there's 1,000 grams in a kilogram and there's 1,000 milligrams in a gram. And you can, that's 6 spaces, 6 decimal spots that you can move. Do it either way. Again, this is stuff you probably should already know. It's a review. And we'll review it again on Friday over Zoom. But this should be pretty easy for you guys. All right, derived units, the next section in the book. What are derived units? For area, examples are centimeters squared or meters squared. That's metric, of course. If you use English, for area, it would be inches squared or square miles, maybe, or square feet. You've heard, you're buying carpet for your house. They'll sell to you in square footage. That's a unit of area. For volume, examples would be cubic centimeters, or cubic meters, or in English system would be cubic inches. Memorize. Here's another thing you need to memorize. Memorize that 1 centimeter cubed equals 1 milliliter. Okay? I need you to know that conversion. 1 centimeter cubed equals 1 milliliter, because I'm going to ask you about that on a quiz. Let's look at example 1.4. 1.4. It says in the problem, it says the length, width, and height of a small box is measured to be 1.1 inches, 3.2 inches, and 4.6 inches respectively. So its length is 1.1 inches, its width is 3.2 inches, and its height is 4.6 inches. What is the box's volume in liters? So it wants you to take this inches, calculate the volume in inches, and then convert that into liters. Okay, so how do we do that? Well, first, to calculate volume, it's length times width times height. You should know that from basic grade school math. So you take 1.1 inches times 3.2 inches times 4.6 inches, and you get 16.192 cubic inches. Inches to the cubert, to the third power. That's a volume measurement, okay? Now that we know the volume in the English system, the units of in inches, okay, we need to convert it into liters. How do we do that? Well, the first thing I could do is I can convert this cubic inches into cubic centimeters. How do I do that? Well, I know there's a relationship between inches and centimeters. How do I know that? Because I memorized it. For every 1 inch, it's 2.54 centimeters, right? So I can use that relationship to calculate the volume into cubic centimeters instead of cubic inches. How do I do that? Okay? The way I set this up, try to keep this on my lap. The way I set this up is I take what I calculated my volume to be, 16.192 cubic inches. Okay? And I set up the relationship for every 1 inch, there's 2.54 centimeters, and I cube that. The relationship's the same. I'm just cubing it, okay? And what do I get? I'm going to get my cubic inches, because this ultimately will be cubic inches, and this is cubic centimeters, right? Okay. This will get rid of my cubic inches, and I'll end up with cubic centimeters. 16.192 times 2.54, okay, is, let's see here, 265, and my units is going to be centimeters cubed. So that's a volume estimate, but now instead of inches, it's in cubic centimeters. Now remember, I had you memorize how many cubic centimeters are in a milliliter. One cubic centimeter is equal to 1 milliliter. Okay? Remember that relationship I had you memorize. That's going to allow me to get rid of my cubic centimeters, and I'm going to end up milliliters. So what's 265 times 1 over 1? 265. But now I'm in milliliters instead of cubic centimeters. Now, it asks, the problem says, what is it in liters? I'm in milliliters. I'm not there yet. How do I convert that? Get this in the... So 265 milliliters, there's 1,000 milliliters for every liter. How do I know that? I just know that, memorize my prefixes. This will cancel out my milliliters. I end up with liters. What's 265 divided by 1,000? That should be 0.265 liters. That's my answer. Is that what the answer in the book is? Yes, 2.265 liters. Okay? So there's multiple steps here. This was the hardest problem we've done so far. First, we had to calculate the volume in inches. We multiplied length times width times height to get that. Then we had to convert it from the English system to the metric system. How did I do that? I used this relationship. 1 inch is equal to 2.54 centimeters. I cubed it so that I could get rid of the cubic inches and end up with cubic centimeters. Once I got into cubic centimeters, the volume, I was able to convert it into milliliters because of the relationship I memorized. 1 milliliter equals 1 cubic centimeters. Got rid of my cubic centimeters, ended up with milliliters. The number happened to not change because 1 milliliter equals 1 cubic centimeters. I end up with milliliters, but the problem didn't want it in milliliters, wanted it in liters, so I had to convert that. I could move my decimal point 3 places to the left, or I could set up the equation. There's 1,000 milliliters in 1 liter. I put milliliters in the bottom so that it can cancel. I end up with liters, same number, 0.265 liters. That's the answer. Again, these conversions and stuff is nothing new to you. It may be a little confusing because you haven't done it in a while, but with some practice, I think it'll come flooding back. And we'll review it again on Friday. Okay, making measurements. Second side of the notes. Look at the ruler and compare the English versus the metric delineations when measuring length. Look at the graduated cylinder and the meniscus to measure volume. I don't know, there's on page 17 of your book, you'll see a ruler, and you see the delineations of 1, 2, 3, 4, those are inches, and then there's half inches, 3/4 of an inch, there's all kinds of delineations, that's English. And then if you look at the bottom, the centimeters, a lot of times on a ruler, at the top there'll be English and on the bottom will be metric. That's delineated by the centimeters. And if you were to look at 2.54, if you were able to figure that out, where that is on the ruler, that would where the 1 would land if you were on the English, and vice versa. But anyhow, you look at a ruler, you can see there's an English part and a metric part. We'll use both, but mostly metric. And then on a graduated cylinder, which is nothing but a little tube that holds a liquid, and when you pour liquid in it, what you're going to see is, I'll draw a picture of it for you. This is a graduated cylinder. That's what it looks like, and it has these delineations on there from all the different measurements. And if I took a liquid and threw it inside the graduated cylinder, my liquid would fill it up to a certain point. And what the liquid does is it forms like a half moon. It doesn't go straight across. Doesn't do that. It forms this little looking half moon thing. And the reason is because the liquid has an attraction to the glass or the plastic that makes up the cylinder, and it creeps up a little bit because of electrical charges. And in the middle, it sits a little lower because it's not creeping up the sides. It's not having it's not interacting with the plastic or glass of the graduated cylinder. So you end up with this thing called a meniscus. That's a meniscus. And the way you measure a meniscus, if I remember right, is you measure it at the bottom here in the middle, where this dips down at the lowest point. That's where you measure it. Okay. Let me make sure that's correct. It's been so many years. Pretty sure that's how you measure. Yeah, if you look on page 18 of your book, you'll see a picture of a graduated cylinder, and you'll see how it's half moon shaped. And when you measure it, you're measuring it at the bottom of that half moon, not on the sides. You measure it at the bottom. Okay, so the bottom of the meniscus is what you use for your measurement. Okay, understand that. Moving on to accuracy and precision. This is kind of neat. If you look at page 20 on your book, you'll see a real picture of what the difference between accuracy and precision. I can be very precise but very inaccurate. I can be very accurate and not precise. The data, the way you're collecting the data, it determines your accuracy and precision. Of course, perfect would be being accurate and precise. What does that mean? Accuracy is essentially how correct a measurement is, and the smaller the scale of the measurement, let's say milliliter versus liter, indicates the precision. Okay? You can be more precise by getting better measuring instruments, but accuracy is not depending on the instrument used. Rather, it is determined by the person taking the measurement. What I'm saying there is, I can be accurate, or let's say you could be more accurate. It doesn't depend on the instrument I'm using. It depends on me, and it depends on you as to how accurate you are. However, precision can be fine-tuned by the detail of the measurement you're using. If I'm using something that only measures in liters, and you use something that measures things in milliliters, you can be a lot more precise in your measurement than me, because my tool is not nearly as precise as yours. So precision depends on the tool you're using to make the measurement. Accuracy is dependent on the person making the measurement. Okay? Now look at figure 1.2 in your book. You see, there's a target there. On the left side, that person shooting those arrows is very precise. Why? Because all his arrows are in the same little grouping. He hits the same spot almost every time. Very precise. Not very accurate. Didn't hit the bullseye. He's on the outside. Look at the person in the middle. He's all over the place. He's more accurate in that he hits the bullseye once and he's around the bullseye, but he's not precise because all his arrows are so spread out. But if you look at the third person there on the right, they're both accurate and precise. Why? Because he's dotted all around the center part of the bullseye with all his arrows, and they're all